Hello and a warm welcome, everybody. Thanks a lot for joining us for this webinar. Today's webinar is titled Test Automation Frameworks Using Open Source Tools. This presentation is being provided by IDEXL. And in this webinar, you will learn about the what and why of automation frameworks, and also look at a demo of one such framework that was implemented by IDEXL using Selenium. So before I start the webinar, I would like to introduce my company. We are IDEXL. We are founded in 1998 and we are headquartered in Herndon, Virginia. And we have almost 700 people on the ground. We have 700 associates strong. And we have 10 locations worldwide, which includes locations in India, Europe, and US. We have most of the resources that we support the projects with. We have domain certified resources. And we also have partnerships with many of the leading technology and tool providers. You can see the list at the bottom of the slide. And we offer a comprehensive set of services, testing services, and the center of the slide represents that. We have functional testing, automation, test management, mobility testing, performance, cloud testing, accessibility testing, security testing, test tool support, process assessment and assurance, and test environment management. I think with that, I would like to jump into the webinar. This is a quick agenda that we're going to cover today. I will talk about quickly, why automation is required. Most of us who are joining today already know about automation and why it's important. But I'll quickly, browse through that, and then we'll talk about a high-level automation process, and what are the different hiccups that we have with our traditional automation, and what and why a framework is required. And we'll look at the various advantages and types of frameworks, and essentially what are the different components of a framework. And then we'll go about talking about our IDEXL test automation framework, which is purely based on open source tools like Selenium, Hudson, and a few other tools. Finally, we'll also look at a short demo that covers most of the topics or the components that we talk about in the framework. So many of us have been in a situation where we want to cover a large volume of test cases in a short period of time, and at times we have a huge regression testing pack to cover. So in such situations, we look for options where either we can do a risk-based testing, or obviously automation is one of the choices there. So automation does definitely provide improved efficiencies, productivity, and predictability, and which tremendously help the organizations to optimize the testing time. So this is a no-brainer. So most of us, that's why we use automation. So if you look at the high-level automation approach, there are three main pillars, or three main core activities that happen every time. One is scripting, where you convert your manual test cases into a automated test case. We execute the test cases, and then you analyze your results to identify if it's a product issue, which is an application issue, or some issue with your test case. You go and maintain your test cases to fall in line with the revised application. That's what you do. On the right side, you see these are the different activities that you do. You prepare the tool, you capture the business transaction as a automated test case, you enhance your test case, you debug your test case, you run your automated test case, you analyze the results and report the defects. So this is on a high level automation testing process. So what are the different hiccups that you see with the automation tools? All seems to be rosy and fine. So why do you have any hiccups at all with the traditional automation tools and the process? So basically considerable amount of time is required for scripting. If you ask me, around 60 to 65% of the time that you basically spend in automation goes towards, invested towards test case creation, automation creation. And most of those automation tools basically use a proprietary coding language. You might have to, either learn a VB or a Java or something like that, some language that the proprietary language that the tool providers give to be able to do any automation with that tool. So in essence, you need experts, automation experts or trained experts to do the automation. And finally, the most important kind of issue that everybody sees in automation is the maintainability. Any small change in the application, UI change or functionality change, you have to go back and update this scripts. But even though we know that all these automation process and tools have their own share of problems, we cannot deny the fact that automation does help in bringing efficiency into your testing efforts. So this webinar basically is not to prove that automation is required, but rather share some thoughts around how to make it better and efficient. So this is basically, we're talking about some of the frameworks that can make it better and efficient for usage. So why does one need an automation framework? The tool works fine. You can go and script your test cases. You can record them. You can modify them, customize them, and you're done. So why do somebody need a framework? So if you really try to understand what a framework contains, you'll be able to appreciate the fact that framework is a necessary support system for your automation. So a framework is nothing but a collection of guidelines like a coding standards, how you handle your test data, how you handle your object repository. So which when followed basically during automation scripting procedure, this will greatly benefit your automation. Like, they improve your code usage, code reusage basically, portability, and also reduce your script maintenance cost. So again, mind you, these are just the guidelines and not really rules. No, they're not mandatory, but you still script without using these frameworks, but you're missing out on the advantages that the framework brings. Like, a framework will automatically enforce conformance to best practices. If you define them into the framework, that will ensure that the best practices are followed, like coding standards, etc. And moreover, if you properly abstract the code with layers, you'll be able to write some test cases in simple English language than real code like a Java or a VB or a Ruby code. Also, this really helps in preserving the knowledge of the test within the automation script, and nobody needs to dig into the code to really find out what we are trying to do as part of the test automation. So this will also, because it brings an easiness of use, you can also increase your test coverage and drastically reduce execution times. So also, if you're trying to build a continuous integration model where you build your code on a daily basis, you deploy that to a test environment at the end of the day, and then you have your test automation run subsequently after the deployment automatically kicked off, and then all that process can be automated using a framework. And your test cases run at the end of the day after the deployment, and the defects that are logged in after that will be routed back to the developer. So it's a continuous cycle that you can engage in if you properly develop a nice automation framework and deploy it. So in a nutshell, what are the benefits of a proper framework? So it provides multiple aspects of support to your testing environment. One is the governance. So the framework will manage all the test execution process, and it provides a central testing reporting and test log and exception handling features that will actually enhance your test automation activities, or ability to do more and better test automation. And it also provides maintenance. So because it provides kind of a wrapper around the automation coding, and the reuse of automation snippets that you create, that basically provides a better maintainability. You can change once, and then the same change applies to all the components or test automation scripts that use the same component. And also the process improvements. It allows the consumers of the framework to basically concentrate on the functionality being tested rather than solving any technological challenges that the tool itself will provide. And it also brings in the standards and best practices that you can include in your automation using this framework. Now that we understood what a framework is and why it is important, let's understand what are the different forms of or types of framework that are out there. There are essentially 4 framework types. One is the data-driven, the second one is the modular, third the keyword-driven, and the fourth is the hybrid. So in the data-driven, all the inputs and output values are stored in data files. So when the test scenarios are run, if you have to get any data, you go to the data sheets and get the values from there. Or if you have to write out any outputs, you go back to the data sheets and write to them. In a modular format, you write small independent scripts that basically represents a small module or a section of application, and use these modules in a sequential fashion or a logical fashion to organize them to form a real test case. Thirdly, in the keyword driven, it involves both the development of the data tables and keywords. Basically, the keywords are basically an abstraction that you provide so that the functionality and the actions that you write on the objects are basically hidden under a layer, and then using that layer is much more efficient and easy of automation. So the functionality of the application under test is documented in a tabular structure like an Excel spreadsheet. So you're not writing a code, Java code, rather you're writing using all the keywords that you created, more like a function calls in a Excel spreadsheet format. And I'll show you some examples or samples where we have a code snippet that's converted into a keyword driven model. And finally, the hybrid model is basically a combination of multiple of these forms or types to form a more efficient and manageable and efficient framework for your automation. So, okay, what constitutes a framework? So there are multiple things that makes the framework. As I said, it's all about making efficient automation happen for your project. So a framework will basically constitutes of n number of things. One is the startup script. This might be basically setting up the test environment and the application under trust. It's a preparatory script. And the driver script basically it iteratively calls the respective usable scripts in a sequential fashion in a test case. And a scheduler which can help schedule your test runs anytime you need them to execute. You can schedule it today and say have it run say tomorrow morning at 5 o'clock in the morning. So you use this scheduler to basically drive that execution any time of the day or any time of the year. And then there's an object repository where you store information about the objects from the application under test, and you have information about the objects, like if it's a text box, what are the different actions that can be stored done on that, and what are the internal names of the objects from the application standpoint and all that stuff. And libraries, these are the usable components that you create and then store them into library, and you use them as a reusable components for your scripting. And then the test cases themselves, the test data files, the environment files, and also reporting mechanisms. So you should have a framework that can report in multiple formats. It's more like it should be able to report in HTML format, XML, XLS, PDFs, doc formats. So anything that can be shared across multiple environments and multiple people, you should be able to handle that reporting mechanism as well in the framework. And finally, exception handling. For example, if say something were to go wrong with the system or the framework that you created, either it should be able to self-heal itself, or you should have a mechanism where it can flag a resource who's tagged as a development maintenance resource for that, so that he can come in and then deep dive and see what's wrong and fix it immediately. So it's kind of exception handling mechanism should also be there. So let's talk about IDEXL test automation framework now. So what we have done for this framework is we've integrated many of the open source tools. We've taken Selenium, TestNG, Ant, Eclipse, Hudson, Testlink, Mantis, Bug Tracker, Monkey Talk, Selendroid, and Appium. So what we have done here is we've tried to create a 360-degree automation framework using all these tools. So Selenium provides a basic engine for our automation creation execution. And Hudson provides a continuous integration mechanism, wherein if you are working on a continuous integration environment, once the deployment is done, we can write some triggers to basically execute or initiate the test automation execution. And that way, we are integrated into the continuous integration environment. And it can also be used, if you're not using a continuous integration, Hudson can still be used as a triggering mechanism for scheduling your test runs. And Testlink for test management, where we map between the manual test cases and the automated test cases. And once the execution happens, we go back and update the Testlink with status of each of the test cases that we executed. And also that will be used as the reporting engine as well. So we report out of Testlink. And Mantis Bug Tracker, that's used for defect management. So we also have created some special plugins for Selenium, where during the execution process, if you find a test case failing, meaning your actual output is different from the expected output, the plugin will get invoked, and then we capture the screenshot of the failure, and we also will capture information about the test step, test case, and the test data that was used for this execution, and create a defect into the bug tracker automatically. And the bug tracker in itself inherently has a workflow mechanism built in. So once the defect is created, it automatically routes it back to the developer automatically. So it's kind of 360-degree automation framework. And the last three components, Monkey Talk, Selendroid, and Appium, we are using these basically for mobile enablement. So we can use the same framework for mobile testing. So Selendroid is for Android, and then Appium for iOS automation. So we have the ability to do both web as well as mobile automation using the same framework. So this is the architecture of the framework. So you can see that we use a hybrid engine, which includes both the keyword driven and the data driven methodologies. And we have a library where we store all the defect logs and then the test results. We also have a test management tool and a defect management tool like Testlink and a Mantis bug tracker built into the system framework. And we also have a reporting mechanism that comes out of our test management tool. So it has different formats that it can create mail reports in, and we also have ability to email those reports once the execution is done. And you also see a device hub. So we enable grid mechanism, which means you can connect multiple machines or devices to this framework and execute test cases in parallel. For example, if you're trying to do a cross-browser testing, you have to execute all same test case on multiple configurations of the machines. Meaning, you might have to have a machine with an IE installed, Opera, Firefox, Safari browsers, and different browsers. So we can run the same test case parallelly across all these configured machines with different browsers running on them, and we can assess what kind of results we see across all these browsers. That's how we enable the grid. Also, if you have, say, many test cases, say thousands of test cases, if you want to compress your execution window, you can distribute the test cases into multiple machines. You can have a packet of 100 test cases go against 10 machines, and you're covered with your 1,000 test cases. At the same time, you're compressing your test execution window to 1/10 of the time. So that's how we use the grid mechanism. And we have the ability to do web services testing. We have ability to do database testing and mobile testing as well. So this is a list of all the features that our framework supports. We support data-driven mechanism. We provide automated defect management, meaning we can create defects automatically if something were to fail, a test case were to fail. And we have test management, which means once the test execution is done, we go back and update the status of the test cases with a pass-fail status, and we do use that for reporting as well. We can do web services testing, we can do database testing, we can do mobile testing. And because we abstract a lot of code that's supposed to be written, Selenium basically supports either Java or Ruby. So what we've done is we abstracted the code with keyword driven mechanism, and that provides a lot of ease of use for this framework. So we can now write test cases in Excel spreadsheets rather than really writing a lot of code in Java or Ruby. So that provides ease of use. So people like a business analyst can use this framework. People like, say, developers who don't really want to use Java to write the test cases, rather they want to use spreadsheets for writing the test cases, they can use it. And we also have robust mechanism robustness built into the system. And if any runtime error happens, it's effectively handled, and it also reports the same issue to the admin. So we can go in and take a look and fix that issue. And I was talking about the grid execution. So we support multiple machines. We can execute parallel testing, or we can execute the same set of test cases parallel across all the machines, or distribute the test cases across all these machines that we have in the grid. And finally, we have the ability to create test data. Given a format of data, we have the ability to generate a tool that generates multiple data sets, and they can be used as a data-driven sheets. So that's about the ITA features. And looking at the mobile, now we enhance this to support mobile as well. So our framework supports automation of iOS and Android platforms. We also can do cross-platform compatibility, meaning a test case that might run between web and a mobile and back to mobile or web. So we can do that kind of testing where your scenario jumps between mobile and web kind of scenarios. And we have a set of devices that are set up in our offshore lab in a secured environment. And we also have grid mechanism which provides the productivity. And because of the keyword mechanism or framework that we have, we also increase the ability to create test cases and ease of use of test cases. That will also increase our productivity. So earlier I was talking to you about showing a sample, right? This is how it is. On the left side you see a Java code that we write for a test case. On the right side it's a keyword-driven Excel spreadsheet which shows what are the different actions on which object and what is the command that we need to use and where does the value come from. You can you have INP call name, right? That's a value that we bring from an input file. That's a data-driven file. And then we pass that variable or value to the object that we're acting on right now. So it becomes much easier to write the test cases this way rather than writing the Java code. And it'll be much more easy to maintain as well. And this is a sample of the report. So we can generate multiple reports in multiple formats. And if you see the bottom part, that's a summary report example. By each test case, if it's a pass or fail, if it is failed, what is the defect ID that we capture for that particular test case? So these are the different kinds of reports that we generate from ITAF. And this is again a detailed test report which shows step by step and finally what the status is. And if you have if you want to run the same test case for multiple iterations with different data sets, it will also show for each iteration what is the value and how did the testing progress. This is a very detailed report, step-by-step report. So generally for your management, if you want to run the reports, this is more better report. A summary report is what you show to your management. Okay, now we have ITAF, but how does it help in the continuous integration process? So once you have your ITAF test framework integrated into the continuous integration mechanism, it can support your testing in multiple quality gates. So if you are doing a test execution in QA, it can support end-to-end regression testing. If you are working on alpha beta kind of releases, you can schedule your test runs to test your alpha beta releases. If you're testing for localizations, you can reuse the scripts for localizations. All the things that you need to do is change your input files with different localization text, and your scripts are ready for testing your localizations. And if you are in a pre-production or a UAT kind of environment, we can use some of the test cases. Business can pick them. You can run them in support of your user acceptance testing. And if you're into production, you can use the same environment to done continuous monitoring. Now you can drive some synthetic transactions once in a while to see if all the systems are working fine. Anywhere, any issue, we have the automated defect management system which actually flags a defect if something goes wrong and all that stuff. So if you look at the ITAF infrastructure, as I said, we have an ITAF server system and also a grid that connects multiple machines and multiple devices. So we update the defects that are coming from the framework into defect management tools, and they'll also have ability to send out reports to program and project stakeholders. So if something were to go wrong again, it communicates back to the developer and the test engineer about these failures. They can fix the code or the test case and then re-execute the test case again. So this is how it integrates into your continuous integration mechanism. So more than deployment, once you create this tool, it's a matter of maintenance again, because all these tools that we integrated, once in a while they release say fixed packs, or they also release the newer versions of the newer upgraded versions of the tools and all that stuff. So it becomes now an act of maintenance of this complete integrated framework, so that we keep up to date with the newest releases that are coming out. So how we do it, what we do is when we first implement the tool at the customer location, what we do is we try to understand the current versions of the tools that are used. We build a framework with those current versions of the tool. We test it and deploy it, and we keep monitoring for newer releases of the tools. And if, so for example, Selenium goes to next version or bug tracker goes to next version, we keep monitoring that. And not only that, sometimes client might request a newer version. He might be in a two versions down the behind, but he says, I don't want to go to the latest version, but increment me by one more version. So there might be requests from them as well. So we collect all this information, we integrate into the framework, we test it and deploy it. Okay, that's how we implement and maintain the software at customer locations. So this is about change control. How do we control the changes? So once we have the test case repository, we do the automation, and that goes into the source control system, and we go into the build server and then we execute the test cases. So if once the continuous integration mechanism or the unit test cases pass or fail, based on that, we either go back and change the test case or the application, and then deploy the build code or the automated scripts onto the server and execute them. So now we look at the actual product that we have, and there are a few things that we're going to cover. We're going to cover the various components of the framework. Earlier we talked about that. That will include the test scheduler, object repository, functional libraries, test cases, test data files, environment files, and reporting mechanism. We'll also look at the continuous integration, and we'll be looking at the device and browser hub, and a short demo of how everything works in a collaborative manner. So now I'm going to pass the control to technical team, who's going to walk us through the webinar, the demo part.
Thanks, Ankit, for introduction, and hello everyone. My name is Harsha, and I have my colleague Anita. We both work in technical team, and we are actually responsible for developing and maintaining this test automation framework. And in this demo, we will cover 3 scenarios to demonstrate both mobile and browser and PC part. Okay, like we have taken eBay as our test application for demo purpose, and so for the demo purpose, we are failing one test case and passing 2 test cases. And first test case is like user installs the eBay hybrid application on mobile and then launches it and check for default status of show checkbox. And user installs the application in scenario 2, launches it, accepts the terms and conditions, log in and then navigate to the product catalog to select what category in eBay. We pass this test case for demo purpose. And scenario 3, user logs out from the mobile applications and logs in using the web interface on PC to demonstrate its capability on to automate web applications on PC browser. So this is what we are going to cover in this demo. And for the failed test cases, we are assuming that by default this checkbox should be enabled. Otherwise, we are failing it, just for the sake of demo. And to start with, actually, like we will. So this is the test case document. As Venkat was telling, actually it is completely, ITAP is completely now keyword driven and data driven framework. And this is the test case document. And in this test case document, we can write the test cases in terms of actions, objects, and commands, value, and we can have, for the convenience purpose, we can also write the comments here. And for every action, we will have a command. So for example, we have actually like for action execute, we have type, check, and select, and close, etc. command. And we have an object input here. This object may be XPath or is like we can give link, ID, name, or class as the objects here, and based on the convenience and based on the development practices and like based on the test practices. And also is that we can give the commands here, and these are the values actually. Let's say, for example, if you are giving some input file, actually we can give it as a variable here so that we can read it from the data file. And if we are expecting some values to be displayed, we can give it as a variable and we can read it from the input file. So this way, actually, we have segregated like data from the test cases, so that in any case, actually, like during the development or the engineering process, if something changes, okay, like we can change the input files and we can continue with the testing rather than changing the test case itself. And we have written almost 30 plus keywords and command combinations using which mostly we can automate any of the application. But these are all simple wrappers around the APIs from the open source. And what we can do is like we can develop extra like wrappers or actions and command combinations for the project need as well. But from more experience from the past projects, we can cover almost all the test cases using this keywords, whatever we have written here. So this is the input data. Actually, is like what we are doing is like in EVA applications, we are is like giving username and password as the input. What we have done is like we have written the username and password, and we have from test case will read the username and password from this from here. Actually, is like it will read this file from here and it will start executing it. Actually, in case if you want multiple users or like users has to be logged in, actually we can append this list with the multiple usernames and passwords, and then we can execute the test cases. So that's what it is. And here in this expected data, we have one more thing. Actually, like one more file called expected thing. So for example, we are verifying this message. Actually, like in this terms and condition, we are verifying this message. Actually, like like this is the error message. We are verifying these messages in our test cases. So it's like these things. Actually, we can read these strings and we can give the corresponding the variables in the test case document, and we can automate it. Actually, like so. In this way, actually, we are segregating the strings or expected strings, like input strings, all those things from the test case document. So, in case actually, like if something changes during the course of engineering, we can change this files. In fact, actually, we can get these files. Actually, the corresponding strings, variable names, and the corresponding strings from the product management as well as from system unlist. Okay, like these strings, and we can directly integrate with our test case scripts. So that's that way actually that we can reduce that of testing effort. So this is what is the execution file in our framework. So it's like what exactly is this file contains is like this contains the list of test cases we have developed. Okay, it's like in case actually if we add 100 test cases, we can write down the headings, like the test case IDs of these of all the test cases of the scripts in this file. In any case, actually, it's like we can mention whether to run these test cases or not in that particular quality gate. Say, for example, we can write 100 test cases for feature regressions or functional regressions. But if build team wants to run subset of those test cases, only 10 test cases for their build validity, so they can choose only 10 test cases and they can execute it. This means actually we can reuse the same test scripts across all the 2 quality gates. And using yes or no, actually, like you can choose either yes or no here in this column, and you can before running the test scripts, and you can select the test cases and you can run it. Actually, that way actually that we can reuse these same test scripts across the quality gate. And this is environment file sheet, and in this environment sheet, actually, what we are doing is like how we are giving, it acts almost like a configuration file to the test execution. That means, say for example, if you want to execute the test cases in series or parallel, like that, actually, when we have a grid of browsers, a grid of mobile devices, if the same test cases has to be run on all the devices, or like we can run one test cases on the first device and second test case on the second device, or third test case on the third browsers, like that. And defect log is like automatically is like ITAF is having a capability to log the defect if it finds to the test defect tool like Mantis or Bugzilla. So we can instruct here whether we need to ITAF need to log the defect automatically if it finds, or like not to log the defect. If you say yes, it automatically captures the screenshots and like it will update the defect tracking tool, and next day is like tester can come and modify those defect logs. That way it will reduce a lot of work for raising the defects. And what kind of defect tool we have to use, we can instruct here, like like we ITAP supports Mantis, Bugzilla, and other open source tools as well. So it's like we can choose this. And whether we have database testing and report testing, all that kind of web service testing, whether to do all those things, we can configure here. And through email list, actually, the once execution is completed, ITAP is having a capability to send the test report to all the stakeholders, and we can configure which the groups here, so to which group or which email ID it has to go. The reports has to be sent. All the stakeholders' email IDs, we can list it here, and it will automatically send to those email lists. This is what is the environmental sheet. And once test case is execution is test script execution is completed, it automatically captures all the screenshots wherever it is failed. Say for example, if we have already run one round of testing here, and by default it has to be checked. This checkbox has to be checked. So it's like it is not checked. So it's like for that particular test script, it has logged a defect. Actually, like it has captured this screenshot, and ITAP will automatically is like take these screenshots, and it will go and attach this as a screenshot for that particular defect, in Mantis or Bugzilla. And also we have we will have HTML reports, as Venkat was telling. As Venkat was telling, actually this is the detailed test report. Actually, for the testers or developers, okay, like if they want to analyze which particular test step is being failed, actually it will give all the test detailed test case by test case, actually which test cases step is failed, and all those things, and at what time, and what was the actual result expected by the test script, and what has happened, and this is failed or passed it gives. It's like it is easy way to debug and like analyze the test report and go to that particular script and look at the screenshot and analyze the defect. This way, actually, it will use the testers and developers. And also is like for the program stakeholders, it also generates the summary report like this. It's like we ran 2 test cases here, and one is passed and one is failed. If there are 100 test cases, it will give the detail, the summary report to all the program stakeholders. This one. And it also gives the logs. So, for example, if there are any particular errors, it gives the details, error type, actually, like what exactly has happened, and it can act as a good debugging input. This one. So, for the ease of demo purpose, what we have done is like we have recorded the demo because ITAF takes a lot of time for processing the test reports and execution and setting up the grid. To fit the time, we have recorded the demo. So we will play that and we will explain that as it runs. So this is what is the Hudson actually. It's like we have integrated this with Hudson, and for that sake, actually we can integrate with Bamboo and Jenkins as well. And this is so it's like for the demo purpose, we have integrated with this with Hudson, and we are giving the demo. And what it is doing is like this is one of the device actually is like attached to this server, ITAP server as well. Actually, is like we have for demo purpose will showcase two devices as it goes. And once this Hudson, we can schedule the testing using Hudson, and this is the grid hub. Actually, is like using this grid hub. Actually, what we can do is like we can set up a browser hub. Is like we can set up like different browsers and the different PCs, and we can control with grid server. And we can also connect the multiple devices, say for example, hundreds of devices to the multiple PCs, and then PC connected to the grid hub. So in this way, actually, is like we can test it on the multiple browsers, multiple browser versions, as well as the multiple devices for the single application. Okay, it's like the best part of this ITAP is like for the devices. So for example, we can write a single test script which can run on the different devices. For the demo sake, actually, we are running the same test script on 800 by 480 resolution and 800 by 1020. So now we are building the test script. So this is one more devices connected remotely, and is like this is the simple interface ITAP provides, and you can see the execution of the remote devices as well as the connected devices using this simple interface. And we have connected two tabs here, and so is that we can also control the devices manually using this interface. And while running, we can also see the execution in the server. Actually, it's like ITAP server. So that actually if anything goes wrong, or like if it's like we can immediately take the actions, or if it is nightly executions, in order to do that. As I said, actually it's like these two devices are, one is 800 by 1280 and 800 and 480 resolution. And one we are failing because of checkbox, and another we are passing. So it has started execution. So it is by default it is not checked. So it's like we are checking, and we are exiting the test case. So this we are failing, and we are stopping the execution here, and this will continue with the test case on eBay. So it is, like it validates all these menu items as well as gestures, and also is like it will validate all the strings present, and it can navigate, scroll down, scroll up, all those actions it can take care. It can select, like we are selecting the main search. So we are exiting now. So this is complete on test cases. So now what it will do is like it will log the defects in Mantis automatically. It's like we have set now logging the defect to the to yes. So it's like it will log the defect Mantis. It's like next day it can come, and it will fill up all the default fields. Next day tester can come, and he can change the severity as like priority based on his analysis, and you can finally submit the defect. It will like reduce his effort for logging the defects. So it will also attach the screenshot. Okay, like here it is attaching the screenshot, and now it is exiting. So it is building, is like it is still under process, and it is creating all the reports here. In the background, it also updates the test link as well. Okay, like that we will show it in the next video. So this is what is the which is just created for this particular test run. And as you see, it's like we have one pass and one fail test case. And it also says Testlink, that is the test management tool, is been updated. So for example, ITAF is having capability to update the defect tracking tool as well as the test management tool. If we have 100 test cases written in the Testlink, it goes and up whether each particular test case is passed or failed, so that tester need not have to update the Testlink manually. It's like it will reduce the effort there as well. So now if you open the Testlink, it will have the updated test case. If you look at, we ran, it has updated both the test cases. So this defect ID for that particular defect in the Mantis is also updated in the Testlink. So this is what is the screenshot talking about. This screenshot is directly attached to the Mantis in the bug tracking tool for ease of analysis and debugging purpose. So this is the detailed report we generated for this particular test run. And this detailed report is created so that, okay, like each and every test case, the multiple files, HTML files is generated, and it will cover whether that particular test step is passed or not. So as we were telling, actually, this is having a capability to test both web and mobile applications. Now, for the demo purpose, what we have done is like we have written 3 test cases, as we said, or 2 on mobile applications, 1 is on browser, and this is having a capability to run it on different browsers as well. Actually, it's like we can run the same test script on Mozilla, Internet Explorer, or any other browser, popular browsers in the market, and we are running the single test cases. As we were talking, we can instruct the ITAF whether to run a particular test case or not. And we are disabling 2 test cases in this for the browser on the PC run, and we are enabling only 1 test case, and we are running it. We can build the test case script. So it is building the test script for. So it is launching the ebay.com on web browser. we are passing this test case. So it's like we are signing in here with the test case. So this is what is signed in. Using this, we are signed in and we are logging out. We are verifying whether that is displayed. Then signed, like username is displayed, and we are logging out. And once the execution is completed, it will start generating the report. So you can see the report as we as we seen in the mobile execution as well. So this is how actually like ITAF is capable of handling both web browser as well as mobile, and also we can create a like grid of browsers as well as mobile devices to execute end-to-end execution of the mobile application. In case if you have any enterprise mobile, web enterprise applications or web applications, we can also use ITAF on to execute web applications as well. So it's like this completes the demo. Venkat, over to you.
All right. Thanks, Harsha and Anita. So that's about the demo, and I'll open up the floor for questions. I know we are 2 minutes past the time. I'll open this for a few minutes and then see what kind of questions we see. We'll try to answer all these questions. And if you have any other questions, you have my email ID in the invite that we sent out. You can pose the questions to that ID, and we'll respond back to you in an email. Now it's all the questions time. Yeah, I got a question. It says, can we use other tools like Jenkins and other defect management tools in this framework? The answer is definitely yes, and we have done that in some other places as well. One other question is, how long does it take to implement this kind of framework? It will take at least 2 to 3 weeks for completely implementing this framework, guys. One other question is, can we run parallel test execution for different browsers? The answer is definitely yes. We can run, we can configure multiple machines with different browsers, and we can do parallel test execution, which means one test case will run parallel across all these different configurations. If anybody else have any questions, please do write an email to me. My email address is venkata.dasari@idexl.com. It will be there in your invite. Please write an email with questions, and we'll respond back to your email. And finally, I would like to thank you all for joining us for this webinar, and appreciate your time, and look forward for the questions that you might pose us. All right, thank you all. Have a good day.